Now when I was a little boy, at the age of 5.
This is an example of a competing reaction. Initially, the yellow species begins to form. As the yellow species reaction progresses, a catalyst for the black species reaction is generated. Eventually, the black species reaction dominates and the solution turns black. As this reaction runs, the intensity of the black hue decreases as a catalyst for the yellow species reaction is generated. The solution eventually assumes a yellow hue again. This pattern occurs in a cyclic fashion for the duration of the reaction. This mechanism is known as an autocatalytic reaction.
Shown here is a plot of our digitized data. This graph represents the yellow species. We collected this data by watching the video of the reaction and classified the intensity of the yellow color on a scale of 0 to 4. 0 being no yellow color at all, 4 being the most intense yellow color. We plotted this data against time for 200 seconds.
This is our plot of the reaction data for the black species. It was digitized using the same convention as the yellow species. It should be noted that this convention produced a curve that is inverse in relation to the theoretical mechanism curve for this species.
Shown here is the reaction mechanism used to simulate the reaction observed in the experiment. By modifying the rate constants, we were able to fit our theoretical mechanism to the experimental data.
The overlay of the data is shown here. The red lines represent our fit data, while the blue is the experimental data. Modifying the A0 and K1 values both directly impact the amplitude of the fit peaks. The K2 value inversely impacts the amplitude of the fit peaks, while the K3 value corresponds to the frequency of the oscillating fit peaks.
To achieve the best fit, the theoretical values for X were multiplied by a coefficient of 3.75 to achieve the proper amplitude that matches the experimental data.
I'm a